This lesson very quickly covers the product and quotient rules when it comes to deriving functions in calculus. All right, so the product rule, if I have the product of two functions, and so I'll call one function u and the other function v, and they represent some other functions. So this could have been f of x and this could have been g of x. But to make the notation a little bit easier, we'll use u times v, where y, u, and v are differentiable functions, so that means they're continuous. The formula is it's u times the derivative v plus the derivative u times v, or using the Leibniz notation like this. All right. Now, we might be tempted to say, just the derivative of y should be the derivative of the two functions multiplied times each other, but it actually doesn't work that way. This is a proof that I pulled from Ron Larson's calculus book, the 9th edition, and using the definition of derivatives to show how this is true. All right, so let's go ahead and try a practice problem. Press pause and see if you can do this on your own. Okay, so I gave you a hard one right from the start. We've got a function here, so this is u, and this function is v. So what we're going to do is we're going to find the derivative. So we take the first function, keep it the same, and multiply it times the derivative of the second function. We're going to add that to the second function times the derivative of the first here. All right, so when we derive this just simplifies to 4, and this simplifies to 3 minus 4x. And then we can just do some algebra. We can expand and simplify and get this as our final answer. So hopefully that's what you got. The quotient rule is similar. It's a little bit more involved. Again, if you have the quotient of two functions, we hope that all three of them are differentiable functions, that the formula for the derivative looks like this. So the derivative of the bottom function times the derivative of the top minus the top function times the derivative of the bottom function all over the bottom function squared. All right, and some people use this mnemonic to sort of remember v du minus u dv over v squared. Okay, so let's try an application. Well, first, let's also show that, again, it's not true that it's just the derivative of the top over the derivative of the bottom. It would be nice if that were true, but it's not. Here is why, again, from Ron Larson's book. And so there's the derivation if you care to go through it. Now try this example problem. Go ahead and press pause. Okay, so using our formula, we're going to have the bottom function times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And again, you just simplify. The derivative of this just becomes 5. The derivative of this is 2x. You multiply it out. And then you can simplify the numerator and get a function like this. Okay. And then if you had to do the second derivative, of course, you would just do this all over again, where this would be our u and this would be our v, and you can continue on. Okay. Now, you'll get some challenging problems, of course, to make sure that you can follow all the steps meticulously without making a mistake. And so if you were to see this, you would probably say, it's a quotient. I'm going to go ahead and use the quotient rule. But you should pause, you should hesitate and see if there's any way that you can make this easier. So pause and see if there's any way you can simplify this. Okay, so first of all, you can take the coefficients here and move them out front. All right, and that simplifies it a little bit, but then you can should recognize that you've got some common terms here that you can divide out, you can get this, which is much easier, and then you can actually distribute this to get a polynomial. So we can take this and transform it all the way into something like this, which becomes very easy to derive. You can even do it mentally. It's just negative. It should just be 6 over 7, right? So it is worth it to pause and see if there's any way that you can take any complicated looking problem that I give you and make it easier before you go straight into any of the rules. All right, and that is it for the product and quotient rule.